So we're given a function that represents a car's velocity, and we just want to find the car's average velocity between the values t equals 1 and t equals 4. Recall that the average value of a function on an interval a to b is given by the integral of that function from a to b divided by the length of that interval, b minus a. So in this example, all we want to do is integrate the given function between 1 and 4, and then divide that integral by 3. Okay, this should be simple enough. The power rule for integration says we can add 1 to this power. Adding 1 to 1/2 gives us 3/2, and then we can divide by that power. The integral of 1 is just t, and we're going to evaluate that between 1 and 4. Perhaps a step of simplification is in order. Since we have a 3/2 in the denominator here, we can flip that over and put it in the numerator and get 2/3. And this is a matter of personal preference, but if you'd like, you can distribute this 1/3 through the parentheses as well. And we're going to evaluate this integral between 1 and 4. Fundamental theorem of calculus says we plug in our 4 first, we subtract, and then we plug in the lower limit. The rest is just simplification, but sometimes the simplification can be the trickiest part. Notice that anything to the 3/2 power means we take a square root of that thing, and then we cube it. If we take a square root and cube 1, we're just going to end up with 1. So that simplifies pretty well. If we take the square root of 4 and then cube that, we get 8. So that's going to make this a 16/9. So it looks like we can combine the terms that already have common denominators. If we want a final fraction here, we could call 1 9/9, and we get 23/9 as our final answer. And trying to remember what this problem was all about in the first place, we were trying to find a car's average velocity, and maybe 23/9 is not an answer that you would typically give somebody for that type of question. This ends up being 2.55 repeating meters per second because the problem was given in meters per second. Okay, that's the final answer on that one.